Looking at this map isolating Bali and Lombok, you can see how incredibly close they are. If you stand on the eastern shore of Bali, Lombok is a short 22-mile boat trip away. Cross that narrow channel, and the natural world completely flips. The birds and mammals living on the eastern side belong to an entirely different ecological system from the ones in the west. To understand why this close proximity is an illusion, we have to look back to the last glacial maximum. This cross-section shows the ocean floor between landmasses. During the peak of the last ice age, massive amounts of Earth's water were locked in ice, and global sea levels dropped by exactly 110 meters. This massive drain exposed shallow land bridges that physically connected many of the world's isolated territories. But the Lombok Strait is a geographical anomaly. The water here sits in an incredibly deep oceanic trench. Even with the oceans drained, this channel remained flooded, acting as a permanent, impassable moat for terrestrial animals trying to migrate. In the 19th century, British naturalist Alfred Russel Wallace observed this sharp biological divide. He documented the exact waters where Asian species abruptly stopped and a completely alien ecosystem began. Today, we call this boundary the Wallace Line. It operates as a geographical shield, protecting the western gateway to a distinct, isolated continent, Australasia. If you cross that invisible boundary and look southeast, a massive, isolated realm opens up. Tracing the Wallace Line reveals a western frontier of islands, Sulawesi, Sumbawa, Flores, and Timor. Moving southeast hits the region's heavyweights, New Guinea, Australia, and Tasmania. Finally, the borders push east, wrapping around New Caledonia and New Zealand. Today, human mapping divides these landmasses into several separate political jurisdictions, containing parts of Indonesia, all of Australia and New Zealand, and Papua New Guinea. Underneath the soil and the seafloor, the bedrock ignores those drawn borders. The geology unites this scattered area as a single contiguous entity. Why would a puzzle of islands and sprawling landmasses spanning thousands of miles share the exact same natural history? This model shows the prehistoric supercontinent Gondwana. It held the ancient ancestors of all Australian life, before tectonic forces fractured the plate, tearing it apart. The fragments drifted over millions of years, locking into the current positions of Australia and surrounding islands. Australia is unified by its geological birth. The scattered pieces we see today are all remnants of the exact same prehistoric origin. Panning out to a wide globe view of the Pacific clears up a common mix-up. People often confuse Australasia with Oceania. Oceania is a broad neighborhood, an umbrella term covering all the thousands of islands spread across the vast Pacific Ocean. Australasia sits inside that neighborhood. It is a specific, tightly bound geological subregion operating within those wider Pacific boundaries. We usually learn that a continent must be a single, unbroken block of land you could walk across from end to end. The reality is far more complex. It can be a scattered mosaic of nations and islands, held together by ancient tectonic roots and guarded by a deep water trench that not even an ice age could erase.